Good evening, everybody. Welcome on in. It is Friday night, my friends. Sorry, I've rearranged things on my desk, and I'm having to reach around things to, to switch headphones over and all kinds of things. And I still have to do my social needs here, so 1 second while I take care of some things here. But streamer live dev. I'll say GameDev, I guess. Why not? Anywho. Welcome on in, friends. Welcome, welcome, welcome. Hope everyone is doing well. Hope you're all healthy and happy and all of those things. Hope you're kicking butt, taking names, and ready for a good weekend, or gearing up for a good weekend, hopefully. 1 second here. All right, I can at least bring up the screen anyway. I just have to. I don't have it on my monitor yet. So give me a minute here. That should do that. Hopefully. I've been moving things around and getting stuff set up here. I think I have Bazite set up and stuff. Okay, so that's good. We got that going. Let's get this started. I think I have my mini gaming computer just about ready to go. I have it plugged into all the things. I haven't tested it yet. That would probably be a good idea to do at some point. But I have not tested it yet. And yeah, sure, update. But I'd like to do that. We might have a first proper look at it soon. Proper gaming session with it soon. We'll see. See how it goes. But I think think I've got things ready to go with that. We'll see how it all pairs together. But anyway, we're going to jump back on in here to some more game dev stuff. So when we last left, we had just succeeded at getting the Vulkan to present a blank screen here. So if I run this, yes, we have the blank screen working, which is good. So we've gotten that far, which is quite the feat. Given everything that we've looked at, has been quite the feat just to get that far. So we've got that working for us. So now it's a matter of we got a couple more chapters that we're going to have to do. We're not going to do all of the chapters because each one of these actually does something with the final results here, like making a triangle or something like that. And I already have code to load in a model and stuff like that. So what I'm going to try to do is do the foundational things that I need to get me to loading a model, if I can figure out what that is, and just kind of move on to the next chapter and then move on to the next chapter until we get to, I believe chapter 9 is where we actually start loading, or no, I'm sorry, chapter 8 is where we start loading complex models and textures and stuff. So I'd like to get to this port. We're not going to get this far tonight, definitely not, because there's there's so many things. There's so many things to go through. But I can at least, we have our next goal anyway as to what we need to get to. So there's that. Cool beans. Also, I have grabbed, it is Friday, so I'm going to treat myself by grabbing an adult beverage. and try to achieve that perfect Balmer curve. Okay. We're getting lubed up here internally. Okay. So let me see what to do here. So I think what I need, and this, I should have been doing this before. Ooh, just a little bit more there. I should have been doing this before, but I wasn't, because I'm not really thinking. But what I want to do is I want to duplicate this window. I kind of wish I could do like a side-by-side window. I mean, I could, but I'd have to make them actual windows and not just tabs. I kind of want like a, I think, isn't it Opera or something that makes like, you can break up a tab into multiple pieces or something? I could really use that right now, like a horizontal break or something. What does this do? New tab to, oh, I know what that does. Never mind. I don't know what add tab to reading list means. I've never used that before, so I have no idea. Anyway, getting easily distracted. That is the name of the game today. I have been easily distracted today on many fronts. Okay, what are we looking for here? So I've got, this is all the files there, and then over here we're looking at Vulkan buffer. If we want to display 3 miles, we first need to load all the vertices information to define them, and that needs to be stored in buffers accessible by the GPU. Buffer in Vulkan is basically a bunch of bytes that can be used for whatever we want, from storing vertices to storing data. Create a new class called Vulkan Buffer to manage them. Sure. Buffer. Constructor just receives the device that will be used to create the buffer, its size, a parameter usage, which will state what the buffer should be used for, and a bit mask. The last parameter is used to set the requested memory properties that the data associated with this buffer should use. We'll review how these last two parameters are used later on. This class also defines an attribute named mapped memory, which is a handle that will be used when mapping the buffer memory so it can be accessed from our application. In order to create a buffer, we need to set up a structure named create info. We can invoke create the buffer handle, yeah. Treat the memory requirements of the new create buffer by calling that function. The next thing we do is allocate the memory again. In order to achieve that, we need to set up a structure named allocate info. Okay. In order to fill the memory type index, we call memory type from properties method from the Vulkan utils class. It's defined like this. Physical device type bits mask. Okay, it's a little utility class there. Type bits is a attribute is a bit mask which defines the support memory types of the physical device. The bit set to 1 means the type of memory is supported. The required mask attribute is type of memory that we need. For example, that memory will be accessed only by the GPU or also by the application. This method basically iterates over all the memory types, checking if that memory index is supported by a device, and if it meets the required type. VK allocate memory to allocate the memory. After that, we can get to finally allocate size and get a handle a chunk of memory. We also allocate a pointer buffer used in other methods of the class. Bind buffer memory. So we need to link the allocate memory with the buffer handle. Okay. Structure is now finished. The next methods are usual cleanup and some getters for properties to find the buffer. Find two methods to map and unmap the memory associated to the buffer so it can be accessed from our application. If they've been created with the flag VK memory property host visible bit. More on this later on. The map method just calls the VK map memory function, which returns a handle that can be used to get a buffer to read or write its contents. The unmap method just calls VK unmap memory to unmap the previously mapped buffer memory. Okay. The format of that data, we need a vertex description. Vertex input state info, which just stores a handle of that structure. Okay. Describe the input we'll have in our shaders. Text buffer structure. Loading the data. To load the data into two buffers, one for the positions of the vertices, another for the indices of the triangle coordinates that will be used to actually form triangles. Hold the information for 3D models. It will hold the buffers for different meshes that compose a 3D model. Okay. So we have that. List Vulkan mesh. Mesh list. And that's a record. Okay. Mesh data. Vulkan model. I know I'm kind of glossing over these, but I'm kind of trying to just get an idea. I learn better by looking at the actual code, but once I look at the code and I see something that doesn't make sense to me, then I can read some of the text here. But okay, so it seems to me like we definitely want all of those, and then we'll have to get the shader programs and stuff. Okay. Which I can hopefully still use the shaders that I have. It's just we have to set them up for Vulkan and not just for OpenGL. Although they're using shader C to compile the shaders. Okay. Which is the one thing I didn't... well, I do compile them. But I don't compile them to... I don't actually... they're compiled in memory. They're not compiled to Spear V, which this looks like it will compile them to that. I'm wondering though, and I think once I compile these, I can use that still compiled file for OpenGL. I think the newer versions of OpenGL have a thing for it, but I'd have to look and see. We'll have to cross that bridge eventually when we go back to the OpenGL stuff. Graphics pipelines creation, pipeline cache. It's very common to have multiple pipelines. Pipelines are almost immutable, so any variant on the setup at a different stage requires a new pipeline instance. Or to speed up a pipeline creation between creation, Vulkan introduced the concept of a pipeline cache. Allows more efficient pipeline creation by reusing the common parts between them and also between application executions. It is possible, for example, to persist the contents of the cache to disk and load them at startup time in the next run of our application, reducing the time required to create them. In our case, we will limit at this time the usage of the pipeline cache. For now, we'll just use it to speed up pipeline recreation during application execution. Okay. So pipeline stuff. And then that triggers changes to render and forward render activity. Okay. And you got shader code there. Okay, so, all right. We got a couple files we need to do in their entirety. So I guess we'll start with Vulkan buffer here. Let's bring that up. Okay, so what do I need? So public class Vulkan buffer. I guess the question is, where do I put this in my hierarchy? Well, it takes the device, right? So I'm guessing I should put it under device here. Let's say Vulkan buffer. And what do we need? Allocation size, buffer, logical device, memory, a pointer buffer, and requested size. So they're all longs except for the device and the pointer buffer. Okay. And mapped memory. So allocation size, buffer, memory, requested size, mapped memory. Okay. Allocation buffer is just allocation size. Buffer is just the ID, right? Yes, buffer is just the ID. So allocation size ID. Memory and then requested size. What is... I think that's also a handle. So we'll say... And... requested size and mapped memory. that's a handle as well. So requested size and then we want private. Device and pointer buffer. These all filed up, right? Yeah, whatever. All right. Let's do the constructor here, and I think it takes a device size, usage, and mask. Size, usage, mask. This requested size. Map to memory equals no. That is memory util. No. Okay. Which, yeah, I don't know why they do that. Just do it there. Okay. So we need a memory stack and then a VK buffer create info. I forgot. VK buffer create info. What else? The type is structure type buffer create info. Buffer create info. Size, usage, sharing mode. Sharing mode exclusive. And we need a long buffer to store the handle temporarily. Just one, yeah. I had a brain fart there for a minute. I'm like, wait, where am I going with this? Okay. So, and then we do Vulcan utils, fail if needed. VK 14 create buffer. VK create buffer. Device ID. Buffer create info null. LP, okay. Device. Buffer create info null IP. Or LP. Buffer is LP get. So this.id equals okay. So VK memory requirements. VK get buffer memory requirements. Okay. Oh, just call malloc stack. Oh, okay. VK get buffer memory requirements. Okay, and then we need the device. We need the buffer. And then the memory requirements. So it's ID and then memory requirements. Okay, so ID. Then did I not do memory requirements here? Oh. Duh. No, I did it. I was looking in the wrong spot. Memory allocate info. Type is structure type memory allocate info. allocate info. Allocation size. Requirement size. Memory type index. Okay. I need that utility. All right, so memory type index there. We'll save that for a second. Let's pop on over to the utility here. And let's do that. Memory type from properties. Public static int takes physical device, type bits, and mask. Okay. I'll just say type. Type and then mask. Type from properties. Okay. Public static int memory type from properties. Physical device, int type, int mask. Okay. So result -1. So let me see what I can do with this. So VK memory type buffer memory types. Is that right? VK memory type. Oh, memory type dot buffer. Device get physical device. Why wouldn't I put this just on the physical device thing? This is another one of those where I'm like, why wouldn't you just put this on physical device? You don't have to pass it in, right? Or I mean, I guess you still have to well, no. You just do get physical device and then yeah, like why wouldn't I just put this here and say public int get or return result. Result is I memory type. This first of all, this method is poorly written. Right? Because it's just kind of... Yeah, it's poorly written. Like, again, this feels like something they just copy pasted and maybe changed from like C or something without really thinking about it. Right, because yeah, it's weird. I say that because well, in fairness, they're doing the principle of one as few return statements as possible, which under normal circumstances is fine. But in reality, when you've got a loop like this, just don't even break. Just return results. Right? Because you're going to break out of this loop immediately, which means you're not going to run this line at all. And you've got your results, so you're just gone, right? And down here, if you happen to fall down to this, right? And yeah, you don't even need if a result is less than or equal to 0 here. Like, you just throw a new runtime exception. Done. Right? Like this method has more branches than it really absolutely needs. Right? You just return result here. Or really return I. And then if it falls out of loop, throw a new runtime exception. Meaning you didn't find the memory type. Like anyway. But even then, putting all that aside, like, why isn't this on the physical device method like I'm doing? Like, it's just because it's accessing memory properties, memory types, all this stuff. It's like, why does this class need to know about what this class has when this class knows about what this class has? Right? And we're passing physical device around every goddamn place. So use it. You know, just say, hey, physical device, you know, does your memory type equal the things I've passed in? Yes or no? Right? Or at least, you know, it's not really a Boolean yes or no. It's really just give me your memory type back. Which it's not even really that, right? Like, what is it return? It's returning the index. If type bits end 1 is 1, and the property flags and the mask equals the mask, these are logical ANDs. This is a conditional AND. Then return I, which is 0 to max memory types. Why? So it's doing memory types get I property flags. But there's no validation that get I is going to succeed. Right, like we're just looping from 0 to max memory types. And we're just assuming that that exists in the memory types here. Because if it doesn't, this returns, no, this actually returns a null pointer exception. Like, wouldn't it be better to loop over what comes back from memory types and find the one that matches this conditional? And if there isn't any, then throw an exception? Like, I don't understand why this is completely divorced from this here. Like, there's a giant assumption being made here that really shouldn't be being made, because this thing could throw null pointer exception. Which, I mean, they're throwing runtime exception if they don't find it, so I guess if they... Yeah, that's strange. Let's see what this looks like. So, memory types, VK memory type buffer memory types. Let's say get, what do I call this? Get memory type from properties. I guess I'll just call it that. And then all I need is the type and the requirements mask. Int type, int mask. Right. So VK memory type buffer. Yeah, physical device. Get VK memory properties. There we go. Get memory properties. Memory types. Yeah, this has a stream on it. Yeah. Stream. Filter. Wait, get physical device, get memory. Wait, is that right? VK memory properties, memory types. Is that a thing? That is not a thing. VK memory properties. That Um, wait a second here. Give VK memory properties. Do they have? Did they add something to physical device? Physical device memory properties. VK memory properties. Do I not have that? No, I do have that. Okay. Types. There we go. Okay. I mean, it makes even more sense to have it on there instead of separate. Okay. So wait a second here. He's doing type bits and 1 equals 1. So basically saying if you pass in oh no, okay. So he's doing a bit shift to the right by 1. So he's looking for anything. So he's looking for any values in type bits that are. He's looking for any bit that is 1 in the 32-bit number. So okay. So then, as soon as you find 1, then you are going to that portion of property flags. Oh, I see. So you're. So based on where on the first position you find a 1, this is so screwed up. So based on the first position where they find a 1 in the integer, 32-bit integer, they're then. So basically. I wonder if my drawing thing works or not. Forget the. Oh, there it is. That was. That was not the thing I was looking for, but I mean it is, but it's also, why is it doing it that way? What is happening here? Here's my display configuration. No, what the hell is it called? It's like mouse desktop effects. I think that's what it is. Oh, where's that? Mouse mark. Here it is. Oh, Meta Shift F11. There we go. But why is it, oh, it's just Shift and Meta key. Not Alt? That's not. It's not working. Shift Meta key. No, that's not it. Oh, Shift Alt? No. That's doing the wrong. That's doing a weird one. Oh. Oh, that's not working. This was working before. I mean, it's kind of working, but it's just the wrong. Yeah, it's doing like a weird thing there, so. That's weird. That was working at one point. Maybe it's over here. I don't know why, like, Control Shift Meta works, but it gives me that weird cursor. Huh. That's weird. I did have that working at one point. Anyway. Easily distracted. Easily distracted by shiny stuff, but problem here is so it's using that to figure out the index into the property flag to I don't like that. That's one of those things that's too clever. Right, because if you ever come back and look at this again at some point in the future, you'll get the absolute wrong impression of what's happening here. How do I unclever this thing and make it something blatantly obvious? That is the question here. Kind of curious about something. If I take this and I go over to, I gotta sign in. All right, hang on 1 second. While I sign into this. There's the this. Okay. Bring that back up again. Curious though, if I go into here, I go immersive. Can you simplify the following code block? All the required property flags. Here's a simplified version. Okay. Wait, that's actually more complex. Let me provide a better simplification. I think Claude is trolling me here. I think he's trolling me. Actually, we can simplify even further. Like, what? What? What is going on here? Memory types, integer number of trailing zeros, integer highest 1 bit. The hell are these methods? Do these methods actually exist? Highest 1 bit type bits. Type bits does not equal 0. I plus plus. Okay. If type bits shifted right, I places and 1 equals 1. Smash result. I mean, you didn't really. shift it? I mean, you did and you didn't. I mean, you're still incrementing I. But I'm like, what the shit is this? Integer highest 1 bit? I mean, that's actually if this actually exists, that's probably a better thing, but what the frig? EK max memory types. See, what bothers me is this max memory types thing, but back to int sum. Okay. So yeah. Yeah, Claude is a little bit I mean, he did make it a little bit more on the nose, but not by much. So the problem here is boy, the more I look at this, the more I hate it. I'm just sitting here going, this sucks. Just over and over and over again. Even though to achieve what they're trying to do, it actually is correct. The code is correct. It just sucks. And I'm trying to think of a way to not make it suck while also not muddying the waters either. I do actually like that Claude didn't change the type bits variable. Like, by eliminating this, Claude actually made this better in that you just keep shifting over however many bits you need to, and you're not actually changing the value of type bits. Like this is doing. So Claude actually made it not leak memory, sort of, kind of. I mean, it's not leaking memory, but it's not, you don't want things changing your parameters like that if you can help it. Although these are native ints, so I don't recall if Java is passed by, I think Java is passed by value when it comes to native variables. Like if that was an integer class, it would be passed by reference, and then you would be changing the reference to it, or you'd be changing the value of it. But since it's native, I think it's actually passed by value, which means it's a copy of it is put onto the stack when it calls the method. So I guess you're technically not changing the value of it. Well, I mean, you're definitely not changing the value of it if it's passed by value at that point. So maybe it's okay. All right, I take that back. It's not I guess it's not really doing much there. I guess there's just not a better way to do that. Which just bothers me beyond all belief here, but yeah. Yeah, I don't think there is a better way to do that right now. The way they have it. Okay. So we'll do this, I guess. I won't use the stream things. Yeah. Alright. For int I is 0, I is less than VK14, VK max memory types, which is 32. Yep. I plus plus. And then we're saying, yeah, I'm just gonna do if type shifted I times, because I think that is a little bit cleaner. Equals but it would be, why is that on? That should be off. Stop giving me suggestions. No, stop giving me suggestions. Why are you on? I turned you off. What the hell? Is it the wrong? Where is settings? Copilot. No, it's under key bindings, right? Key map. GitHub Copilot. Copy Copilot. Yeah, disable completions is button 5 click. Button 5 click, yeah. So why is it still giving me suggestions? Yeah, no, stop that. Oh, it's Copilot inline completion provider? No, that's tab to complete. No, I want you off. No, god damn it. Stop that. I want that turned. I want it turned off. Why is that not working? Let's do Control Shift O. Wait, was it Control Shift O? Control Alt Shift O. Great. Control Alt Shift O. All right. Wait, if I do that, do I need to should need to Oh yeah, I do need to do and one on there. That's what I thought. And get I property flags. Okay. Equals the then turn I. Failed to find memory type. Failed to find memory type. I still don't like that, but it's at least a little bit cleaner. Yeah, I mean it's a little bit cleaner. It's still not great, but it's what it is. So then here over in Vulkan buffer, we just do jump back over here. I've lost my syntax highlighting. There we go. Device get physical device. And then memory type bits and required mask. Okay. So get physical device, get memory type from properties, and then it's memory requirements dot memory type bits, and then mask. Yeah, okay. All right. Yep. Okay. So that we have that now. So then, failed to allocate memory, allocation size, the memory pointer, and the allocation pointer. Okay. So VK allocate memory. Allocate memory, and we want device get device. Memory allocation null, and then LP. Wait. Memalloc is the allocate info. So allocate info null, and then buffer. Okay. Then allocation. So this dot allocation size, this dot memory handle. Okay, so this dot allocation size equals that. This dot memory handle equals get 0 and a pointer buffer. Memory allocate pointer. So wait, that's all we're doing there? Until that. Oh wait, does that need to be in a? I guess that needs to be in a memory stack. Yeah, because they didn't do it otherwise. I bet it does. That's probably why. Hey, Farid, welcome on in. How you doing? This dot util dot alloc pointer. Right, and then bind buffer memory. Bind buffer memory. I'm doing real good. Doing real good. Just trying to learn how to game dev. Trying to learn how to make an engine here. Slowly but surely. Let's see. So I just have to bind VK bind buffer memory device, buffer, memory, 0. Okay. Find buffer memory. All right. So whoops. We're gonna have VK 14 VK bind buffer memory. Buffer memory 0. What do they call buffer? Oh, okay, the ID. ID and then memory handle and then 0. Okay, ID. Memory handle 0. To find buffer memory. Okay, so I have that constructor done. And then we get cleanup stuff here. So we're freeing up the buffer there. Destroy the buffer and free the memory. Okay. So buffer and then memory. Okay, so let's do public void cleanup and so then it's destroy buffer and then free memory. Okay. So VK 14 VK destroy buffer. ID. And then, was it null? No. Okay. Or not destroy, free memory device. Memory handle. Null. Okay. And then we have getters on the ID and the requested size. Do those. Yeah, fine. Getter on ID and requested size. And I actually want to put these before I put those. So public void map. Public long map. Okay. If mapped memory is null, then map it. And then unmap if it's not null. Unmap it. And then set it to null. Alright, so if that's memory handle equals EK14 EK null. Is that wait? No. Just null. Oh, it's memory util null. That's what it is. Okay. A map memory, right? Device memory 0. Allocation size 0 PB. Device memory. Handle 0. Allocation size 0 PB. L2 map buffer. And then map to memory is okay, so we set the map to memory to this. This dot map to memory handle equals that. Get 0, right? And then we just return it. Guess this is void, right? On the map. Yep. If memory handle does not equal util null, then VK unmap memory. Device and it's just the memory handle. And then we set map to memory to null. Okay. I hope I'm not getting my handles all mixed up there. Okay, so I think this class is done right now. Oh, there's an error here somewhere. Oh, LP. Where did I put LP instead of LB? Oh, there we go. There we go. That's a little bit better. Why does this have an error? Oh, because I started to write this and then realized this should be there. Okay. That is why. All right, so that's the Vulcan buffer class, and then what was the next one they wanted me to do? Vertex description. Okay. I've got an abstract class, vertex input state info, and then vertex buffer structure. Huh. Okay. So where to put this then? So vertex input state info. Okay. I don't think that goes under device. Probably goes under render. Yeah, put it here for now. I might end up moving some of these things around, but I think under here would be fine right now. Name of it, vertex input state info. Protected VK pipeline vertex input state create info. Vertex input create or state VK pipeline vertex input state create info. VK pipeline vertex input state create info. Alright, and then it's just a cleanup and it just calls free on it. Okay. Okay, so we have that. This is just checks though, right? Must be private and have accessor methods. It does have accessor methods. Yeah, you know what? Let's do this. Let's do private, and we'll do a protected setter. Yeah, that'll be a little bit better. Um, okay, so then we needed a. What was the wait? What was the name of the other one? Vertex buffer structure. Oh, there it is. Vertex buffer structure. I'm like, why can't I find it? 'Cause it's right there. Okay. Before I dig into this, doesn't look like it's going to be very long here. I need to stand up and stretch for a moment, so I am going to do that. And I'm just going to take a break for 2 minutes, and I'll be right back. Enjoy the music. Okay, I'm back. Sorry for the extended break there, but I really needed to. I wanted to go get some coffee and do some jumping jacks and stuff because, like, there comes a point where I'm sure everybody has the same thing where it's like, you're kind of stretching your legs and stuff, and every time you move, like, you're just all of your bones are cracking and everything. It's like, you're, and every time it cracks, it feels just slightly better and then slightly better, and so you crack it some more, and it's a vicious circle. Before you know it, 20 minutes has gone by. I'm sure I'm not the only one that has that problem. Anyway, my friends. Let's see if let's get through vertex buffer structure here. I do feel my brain starting to shut down a bit, so I think we might just do this class and then and call it. I don't know how far along. I mean, I don't think we've made that much progress into this chapter, have we? I mean, we start with Vulcan buffer, vertex, input state info, vertex buffer structure. And then we have loading the data. So just a model there. Some model data, which is mostly a Pojo, so it's not a big deal. And then Vulcan model has some real code in it, some meat in it. And we still have the graphics pipeline to do and the shaders and stuff. Yeah, this is a pretty large chapter. Pretty darn large. So we've barely scratched the surface of it. And it's been, what, just over 2 hours? Damn, man. This is... I mean, the nice thing about this is, in theory, once I've got the fundamentals in, you don't really have to do much after that. I mean, there's still more things to do on top of it. But once you've got like a working state, in theory, it shouldn't be difficult to get back to a working state. Man, yeah, there's just a lot. Like compared to OpenGL, there is a crap ton more stuff you have to initialize and stuff for Vulkan here. Like at least 3 orders of magnitude more stuff you have to do. And I'm not sure that's better. At the end of the day. I mean, I know what their goals were, but I'm not sure that the way they've gone about it is a better way than what OpenGL has done. I think so. I don't know here. All right, so we'll do vertex buffer structure. Because, I mean, when you think about it, at the end of this, I'm going to have all these classes, all these hundreds of lines of code, and I'll be right back to where I was with the OpenGL thing, which is I'll have a model that loads up and I can rotate with the arrow keys, you know? So that's a thing. And then from there, it's like, I still have more stuff to do with the model, so I still have to like look at what it takes to do the physicality-based rendering stuff, both in OpenGL and in Vulkan. And then that will be all the data that I can squeeze out of the model, at least. And then we can start to look at doing menus. Like there's a whole menu library to use, and I'd like to get into that and start doing some menuing, which then kind of forces us to do a state machine, so we know the state of the, whether keys should be processed and how those keys should be processed, and changing the state of things, because I'll want the menu to be accessible, with the arrow keys and stuff, and probably WASD, but at least the arrow keys anyway, and the mouse. But when the menu's open, you want the arrow keys to be affecting the menu, not affecting the rotation of the model. So that's where all the state machine stuff starts to come into play and all that. So, and again, that's just the foundational stuff. We haven't even gotten into like full scene rendering, and like I'm just rendering one model at a time. I'm not rendering an entire scene yet, so I need to model that. And then I have to look into how to moving and moving 3D models in the 3D plane, some rudimentary AI for them, and then user interface stuff, like on-screen user interface stuff, and somewhere along the way I got to do some logging. I've got to generate some tests. externalize the strings. I mean, that's pretty easy. And then I have to pull over the code that I did, or the configuration I did to compile the game into a executable. Executable installer, and have all that work, which means I'm going to have to likely modularize everything. So we'll be fighting with modules again to make sure everything comes over from the JVM that I need. I mean, A, this is why people use engines that have already been made, and B, people who don't spend years and years working on these things. So there's a lot to be done. I am kind of curious. Chapter 17 here. Oh, so they got like, oh yeah, I didn't even think about sound and music and stuff too. That is very true. Oh wait, am I? Oh, this is the wrong thing. I gotta look. What is chapter 17 here? Is sound. 16 is indirect drawing. Indirect draw commands are, in essence, draw commands stored in a buffer obtaining parameters. Maximize utilization of GPU while removing potential bottlenecks. Okay. Interesting. Bindless pipeline. Very, very interesting. Okay, I'm interested to see where this goes as we go here. Oh, and here's the GUI stuff. Okay. And what's good here is I can kind of use some of this stuff and move it over to, like, you know, figure out where to go from there as far as like the OpenGL stuff too. So, all right. So we're doing vertex buffer structure extends the state info. Okay, and parasite final int number of attributes, position, components. All right. Position components. Okay, attributes and bindings. So vertex input attribute description buffer. Vertex input attribute. VK vertex input attribute description. Buffer. Attribute descriptions, private, VK, vertex, input binding description. Buffer and binding descriptions. Attributes, bindings. Oh, I see. Okay. Attributes, bindings. Wait, what? Oh, PQ. Yeah, yeah. And that's just one on that one. Okay. And then set info pipeline PK pipeline vertex input state create info. Okay. Int I is 0. Get why did they do that? I feel like there's something missing here. I'm guessing there's going to be a like a for loop there at some point. Okay. I'm not going to do it that way though, but yeah, I think okay. Yeah, I have a feeling you're going to put a loop here so at some point. Binding, location I format. BK format RGB as floats. R32, G32, B32 as float, and then offset 0. Bindings get 0. Binding 0 stride. Position components times graph components dot float length. Oh, graph constants. Okay, where's graph constants at? Is that? Yep, it is here. All right, so let's just do utilities, I guess. Yeah, I'll put it up here. Java class. Public static final. Length 4. Int length is 4. Matrix 4x4 size. Okay. (16 times float length). Okay, and then back to vertex buffer structure. So float length here. Yeah, float length, and then input rate, BK vertex input rate vertex. vertex input. Wait, what is it? VK vertex input rate vertex. Input rate vertex. There we go. And S type VK structure type pipeline vertex inputs. Okay. S type VK14 VK type structure type, right? Structure type pipeline vertex structure type pipeline vertex input state create info VK structure type pipeline vertex input state create info VK structure type pipeline vertex input create state input state create info. So silly. Vertex binding descriptions. Vertex attribute descriptions, I guess, is the next one, right? Yep. All right, and then cleanup just calls super cleanup. Bindings free, attributes free. And what was it? It was attributes and then, or bindings and then attributes. Okay. So that is use without try with resources statement. That's fine. That's fine. Maybe final. Okay. All right, so we have those done. It's dipped my toes in, at least. There shouldn't be any breakage here. Yeah, it should still be right where we were, and we are. Because these are all new things. All right, I'm gonna commit this stuff. Start of chapter 6 code. All right, very good. Okay. I think we're going to stop there for tonight, my friends, because my brain is beginning its shutdown process. But thank you so much, everyone, for watching. If you happen to run across this video on the YouTubes and you have a like or a subscribe that you can spare, that would be awesome. Otherwise, thank you so much, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. And I hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
Space!